When we talk about the internet, it's very tempting to think of it as a single computer network, but in reality, it's made up of thousands of separate networks owned by governments, corporations, and individual users. The computers and links that make up the internet are built by a huge number of companies and use a large range of different technologies to store and transmit information. The internet is made possible because, although there are a large number of different types of computer and networking equipment, they all understand a relatively small number of communications protocols. The two most common are the Internet Protocol, IP, which is used to transmit information, and the Transmission Control Protocol, TCP, which provides a structure for sending data over a network. The two are so important that they're often written together as TCP/IP. Since all of our computers understand the same protocols, it appears that they all belong to the same network. The internet is made up of a hierarchy of networks all communicating through TCP/IP. The lowest tier is made up of individual users who might be connected together in a local area network. These small networks are connected to the next tier, which is made up from internet service providers or corporate networks who provide access to internet services. These in turn are connected to higher tiers, such as telecommunication companies, who own the all-important cables that allow data to travel around the world. The topmost part of the internet is sometimes called the internet backbone, or Tier 1. Before data can be sent across the internet, the TCP is used to break it into fixed-size chunks. These are known as datagrams, but are sometimes called packets. Each datagram contains a small amount of data as well as information needed by the internet itself, including the addresses of both the sender and the recipient, and a serial number. The addressed datagrams are passed by the sender's computer to a nearby router, such as one on their home network. The local router extracts the destination address of the datagram and looks for that destination in a table of known addresses. If the destination address is known to the router, then the datagram is sent to the destination computer. However, if the destination address isn't known to the router, it forwards the datagram to a higher level router which has a more comprehensive list of addresses. A datagram might be forwarded all the way up to the routers on the internet's backbone. The higher level routers only need to examine the first part of the destination address to determine where the datagram needs to be forwarded. Once its address is found in a router's address table, the datagram can be redirected to a lower level router, which will in turn forward it to more and more local routers until it eventually reaches its destination. Routers constantly inform one another about their status and how busy they are. When parts of the internet become congested or a router becomes unavailable, other routers will find new paths for datagrams that avoid the problem. IP's ability to constantly reroute data to ensure a reliable flow of traffic means it's entirely possible for datagrams containing parts of the same file to take completely different routes across the internet. When datagrams finally reach their destination, TCP is responsible for restoring the data to its original condition. The serial numbers on each datagram allow them to be ordered so that the data can be correctly reconstructed. TCP also allows the receiver to request new copies of missing or damaged datagrams from the sender. Between them, TCP and IP offer an extremely reliable way of sending data over what might be an unreliable network.